Alright, so for this video we're looking at lessons 8 and 9 practice problems. I went ahead and provided some information. So converse statements is basically where the if and the then part switch places. So the if becomes the then part and the then part becomes the if part. So just switching. And the question is, we call these converses, and the question is, if I do a converse, is it true? Sometimes it is, sometimes it's not. So for example, if you add 2 and 2, the answer is 4. So if the answer is 4, then you added 2 and 2. And the converse of that doesn't always work because there's more than one way of getting an answer 4. You can get it with 2 plus 2, but you could also get it with 1 plus 3. So for the first one, it says if you have two vertical angles, then they're congruent. And vertical angles is the shape of an X. And when we talked about this earlier in Unit 1, the angles are either opposite each other or they're next to each other. Those that are opposite each other are called verticals or equal. Those that are next to each other are called a linear pair of angles, and they always add up to 180 degrees. But if I do the converse of that and say if I have two congruent angles, then they must be vertical angles. And that's not true because, for example, I could draw a square, and there's lots of angles in a square that I can pair up together, but none of the angles are verticals. So so number 1 or A is false. B actually is a true statement. If I have perpendicular lines, then the 4 angles here are right angles. If 2 lines intersect making 4 right angles, then the lines are perpendicular. This is a true statement. Problem C, we did this in Unit 1. So basically, if I have a point that's equidistant from the endpoints of a segment, then that point is on the perpendicular bisector. And if the point lies on the perpendicular bisector, then then it's equidistant from the endpoint. So it goes both directions. That's perfectly acceptable. Problem D, we've been talking about this one in this unit. If I have an isosceles triangle, then the base angles are congruent. If the base angles are congruent, then the triangle's isosceles. That's true both ways. As we talked about with triangles, if you have 2 equal sides, then there are 2 equal angles. If you have 2 equal angles, then there's 2 equal sides. Same thing with equilateral. If I know how many equal sides there are, if there's 3 of them, then I know there's 3 equal sides. If I have 3 equal sides, I know there's 3 equal angles. So if this statement here for isosceles and equilateral could be written in both directions and be perfectly okay. The last one is not a true statement. If you have 2 angles that form a straight angle, such as right here, a 150 and a 30, they're called supplementary angles. They're also called a linear pair. But if the 2 angles are supplementary, then they must form a straight angle, and that's not necessarily true. I could put a 150 on one line and a 30-degree angle on another line, and those 2 angles do add up to 180, but they're not supplementary. They don't create a linear pair, which is called a straight angle as well. So that's the only multiple choice problem in lesson 8. In lesson 9, problem number 4. Actually, problem number 4 is the same problems as the problems here in number 1. So the straight angle supplementary doesn't work because I can put the 2 angles on different lines, for example, and still add to 180. And the vertical angles converse didn't work because I can have, again, angles in the square, and those angles are not vertical. But the other 3 still work. On the last page, I had somebody ask me to do this problem. So you basically have 2 isosceles triangles. You have ADC, and that's the big triangle here, and BDC, that's the small triangle here. And so we kind of work through, and we found the angle right here is 18 degrees. The biggest reason why that works is because you're told that this angle here is 84, and you're told this angle up here is 24. So since this is an isosceles triangle, BDC, then that means that the 2 angles down here at the bottom have to be the same number. So 180, take away the 84, leaves me with 96. Divided by 2 makes both these angles 48. So since this is 48 and this is 48 and the big triangle is isosceles, so that angle is 24, then this angle over here has to be 24, because these two angles here, angle ADC and angle ACD, both have to equal the same number, which is 72. And that leaves me up here with 36 left. So 180 minus 72 leaves me 36. Triangle ABD and triangle ABC are actually congruent by side angle at 24, and then side the double tick mark, side the 24 and the double tick mark. So since the triangles are congruent, this 36-degree angle here gets split in half. It's kind of like doing a reflection. So this is also kind of like an angle bisector as well. So that makes both angles are 18. All right, that's all of the multiple choice problems and those that were asked about in lessons 8 and 9. Again, if you have any questions or any problems, your test is next week. It'd be a great time to send me a question through Canvas. That way we can make sure that any of the problems you have questions about we can address on Tuesday.